Hi class, and welcome to our continued video lesson on 5-6. We're still rationalizing the denominator. This time we're doing it by multiplying by the conjugate. There's a lot of words there. You guys already know what rationalizing the denominator means. Now we're going to talk about the conjugate. So the conjugate, you guys have seen conjugates before. I'm not sure if we ever called them that. But the conjugate, here would be conjugates of each other. X minus 3 times x plus 5. Conjugates are binomials that are the same except for one thing. One binomial has a negative sign and the other binomial has a positive sign. Other than that, the binomials are the same. Watch what happens when you multiply conjugates together. If you take x times x, you get x squared. Outside terms, x times 3 is a positive 3x. Inside terms, a negative 3 times x is a negative 3x. And my last, a negative 3 times a positive 3 is a negative 9. So my middle two terms, if I combine like terms here, 3x minus 3x is 0x. So my middle two terms, they just canceled out. And I get x squared minus 9. That's what happens when you multiply those two conjugates together. Let's just take another example quick. What happens if I have 2x plus 5 multiplied by its conjugate, which is 2x minus 5? The binomials are the same except for one's positive and one's negative. I multiply these two, I would get 4x squared. Outside is a negative 10x. Inside is a positive 10x. And last is a negative 25. Look what happens to my middle two terms again. A negative 10x plus 10x is 0 x's. That should have been an x there. So I just get 4x squared minus 25. The middle two terms canceled out once again, and class, with conjugates, that happens every single time. That isn't a coincidence. It happens that way. Whenever you have conjugates and you multiply them, the middle two terms when foiling will always cancel each other out. So now if we look at this one, we see a square root 3 and a square root 7 in the denominator. So when we see this is a binomial, we need to rationalize, which means get rid of the radicals, by multiplying by the conjugate. Don't write this down for a second. What you guys maybe would do instinctively here is by multiplying by the square root of 3. Well, that helps to rationalize the first term, because if we're going to multiply, we have to distribute here. So a negative 3 times a negative square root of 3 times the square root of 3 is 3, which helps. But now I don't have a rational number when I do the second term, because the negative square root of 3 times, or a negative square root of 7 times the square root of 3 is a negative square root of 21. So I still have this radical here, and I can never ever have a radical in the denominator. So multiplying both top and bottom by square root of 3 does not help, nor will multiplying both top and bottom by the square root of 7 help. So if that's the case, we need to do something else. And that's going to be rationalizing the denominator by multiplying by the conjugate. So you need to multiply by the exact same binomial, except for one thing different. This sign has to change to a positive sign. Other than that, keep everything else the same. So a negative square root of 3 plus the square root of 7. Do that to both top and bottom, because what you do to the bottom, you have to do to the top as well. So now watch what happens. We'll multiply the denominators first so you guys can see what's a good look at what's happening. We have a negative square root of 3 times a negative square root of 3. A negative times negative is a positive, and square root of 3 times square root of 3 is 3. So there's our first term. Our outside term, a negative times a positive is a negative, and square root of 3 times square root of 7 is square root of 21. Inside, a negative square root of 7 times a negative square root of 3. A negative times negative is a positive, and square root of 7 times square root of 3 is a positive square root of 21. Alright, and then my last term is a negative square root of 7 times a positive square root of 7. A negative times a positive is a negative, and square root of 7 times square root of 7 is 7. So there's our denominator. Now look at what happens here, class. We have a negative square root of 21 and a positive square root of 21. I could combine like terms. I could add a negative 1 square root of 21 plus 1 square root of 21 and get 0 square root of 21s. Well, 0 square root of 21s, we don't even write that down because it's just 0. So the middle two terms canceled out once again, which always happens with conjugates. And now we get 3 minus 7, and we get a negative 4 in the denominator. Isn't that something? We rationalize the denominator. I don't see any more radicals in the denominator, and we did that by multiplying by the conjugate. That's how you're going to do all these problems whenever you see a binomial in the denominator. You have to multiply by the conjugate. Let's not forget about the numerator, though. So this 5, we're going to distribute it amongst both terms in the binomial here. So 5 times a negative square root of 3 is a negative 5 square root of 3. Do the exact same thing with the second term, so 5 times the square root of 7 is 5 square root of 7. Make sure you always look here to see if you've simplified it fully. You can't take the square root of 3 in any way, or the square root of 7, you can't reduce that. And there's no top to bottom dividing that you can do. So our answer is this, a negative 5 square root of 3 plus 5 square root of 7 divided by a negative 4. Let's look at our next problem. So we see a binomial in the denominator. Whenever you see a binomial, if there's radicals, you need to rationalize it by multiplying by the conjugate. So multiply it by a negative 11 square root of 10 plus the square root of 2. Whatever you do to the bottom, you must also do to the top. So a negative 11 square root of 10 plus the square root of 2, you have to multiply in the numerator as well. Now class, you don't have, when we FOIL the denominator, we don't need to write down the middle two terms now, the O and the I of FOIL, because they're always going to cancel each other out. So don't even bother writing it anymore, because they're always going to cancel out. So just multiply the first times the first and the last times the last, because that's all that matters. So the first times the first. A negative times a negative is a positive. 11 times 11 is 121, and square root of 10 times square root of 10 is 10. So we have 121 multiplied by 10 is what we get for our first term. The middle two terms cancel out, so don't even write them. And then we have our last term, which means a negative times a positive is a negative, and square root of 2 times square root of 2 is 2. So there's our denominator so far. Let's multiply our numerator by distributing. So we have a negative 4 times a negative 11 is a negative 44 square root of 10. And then a negative 4 times 1, 4 times 1 is just 4 square root of 2. Now let's clean up our denominator a little bit. This 121 times 10, well 121 times 10 is 1,210. 1,210. Did I say that right? 1,210? 1,210, there we go. And then when we subtract 2, we get 1,208. So in the denominator, we get 1,208. So looking at this now, we have successfully rationalized our denominator. I don't see any more radicals. So now that we're here, we got to make sure that we reduce everything properly. So the square root of 10, I can't reduce that any further. The square root of 2, I can't reduce that any further. But look at your coefficients. Here has a factor of 4 in it. This has a factor of 4 in it. And 1208 has a factor of 4 in it. When you take 1208 and divide it by 4, you get the number 302. So you can take out a 4 out of all three of those terms. So that's reducing it. You're dividing everything by 4. So whenever you have those with your coefficients, make sure you do that to put it in its simplest terms. So now you have a negative 11 square root 10 plus 1 square root 2, because we're dividing everything by 4, divided by, what did I say that number was? 302. Divided by 302. There is our answer for problem number 8. Let's keep on practicing this because it's definitely a new concept. We're going to multiply by the conjugate because we see a binomial with radicals in the denominator. So we're going to multiply by square root x minus 2 square root y. Square root x minus 2 square root y. Multiplying these, we'll do the bottom first. Once again, just multiply the first term and the last term because the middle two terms will always cancel each other out. So square root x times square root x is x. And then 2 square root y times a negative 2 square root y, a positive times a negative is a negative. 2 times 2 is 4. And square root y times square root y is y. Voila! No more radicals in the denominator. We are successfully rationalized. Distribute the numerator. 3 times square root x is 3 square root x. 3 times a negative 2 is a negative 6 square root y. So now we take a look. Can you reduce anything? Can you simplify anything further? You cannot. This is our answer. Class, our coefficients here are 3, 6, 4, and 1. I can't reduce 6/4. The reason why I can't do that is because you can only reduce when you can take a number out of all of your coefficients. I can take a 2 out of 6 and a 2 out of 4, but I can't take a 2 out of 3. It's not a factor of it. So unless you can reduce all of the coefficients, you can't reduce any of the coefficients. So there's our answer for problem number 9. Problem number 10. Why don't you guys pause the video and try this one on your own. You multiply by the conjugate, which is the square root of x plus the square root of 7. Square root x plus square root 7, both top and bottom. In the bottom, square root x times square root x is x. There's our first times the first. And our last times the last is going to be a negative square root 7 times a positive square root 7 is a negative 7. So in our denominator, we have x minus 7. In our numerator, we have square root x times square root x is x. And square root x times square root 7 is a positive square root 7x. You can't simplify anything any further. Once again, you can't say x divided by x cancels, because unless you could take something out of all 4 terms, you can't take something out of any of the terms. So you can't take an x out of all 4 terms, so you can't take an x out of any of them. Okay, you have to have that common factor amongst all terms to be able to do that. Number 11, we're going to multiply by the conjugate. So we're going to multiply by 4 square root x minus 3 square root y. Do that to the bottom, do that to the top. 4 square root x minus 3 square root y. In the denominator, the first times the first. 4 times 4 is 16. Square root x times square root x is x. The last times the last, because the inside terms always cancel out. So 3 times a negative 3 is a negative 9. And square root y times square root y is y. So there's our denominator, successfully rationalized. We don't see any more radicals. In the numerator, distributing the 4 amongst both of those two terms, we would get 16 square root x minus 12 square root y. So our denominator is rationalized. We can't reduce the square root of x or the square root of y. So now let's look at our coefficients. 16, 16, 12, and 9. Is there one factor that you can take out of all of them? There is not. You can take a 4 out of this one, and this one, and this one, but you can't take a 4 out of 9. It's not a factor of it. In the same way, you could take a 3 out of here, and you could take a 3 out of here, but you can't take a 3 out of the 16s. So we are stuck. Our answer is just 16 square root x minus 12 square root y divided by 16x minus 9y. That is as simplified as we can make it. It looks like a mess, but we can't simplify it any further. So that's our answer for problem number 11. Okay, problem number 12. Multiply by the conjugate. So square root x minus the square root of 2. If you do that to the bottom, you must do that to the top. Square root x minus square root 2. In the denominator, first times the first is the square root, square root x times square root x is x. And then our last, a positive square root 2 times a negative square root 2 is a negative 2. So in the denominator, we get x minus 2. In the numerator, square root x times square root x is x. And square root x times a negative square root 2 is a negative square root 2x. And once again, I can't simplify this any further than what is written right there. That is our answer for problem number 12. Woo! I bet you didn't think that would ever end. Definitely a tricky lesson. You got to remember that whenever you see a binomial in the denominator with radical signs in it, you must rationalize the denominator by multiplying by the conjugate. When you do that to the bottom, you must also do that to the top. Let me know if you have any questions on that when you get to class tomorrow.